Welcome to the Solocast of Firecode Tech. In these episodes, it's just going to be me, your host, Gus Gagliardi. There's going to be a range of topics, but I'm going to talk about specific technologies, installation standards, codes and how they work, as well as some other interesting topics that don't neatly fit inside of the context of a normal interview. Hello all, welcome to episode 37 of the Solocast series of Firecode Tech. On this episode, we're talking about freeze protection. Yes, I thought that after our conversation about antifreeze systems, that it would be an interesting topic for a solocast to cover some of the freeze protection options for wet pipe fire suppression systems or water-based fire suppression systems. In this episode, we're going to talk about dry pipe systems, heat trace, dry sidewall heads, and antifreeze systems. Well, maybe not antifreeze systems. You can go back and listen to the Solocast on that one, but we'll talk about it as an option. Don't forget to hit that subscribe button so you never miss an episode, and give us a follow on social media. Oh, and if you could do us a big favor and give a 5-star review on Apple Podcasts, that'd be a huge help to the pod. So, similar to our discussion with antifreeze systems, this conversation comes at the preface that you have already determined the codes and standards for the building that you're looking at. You have determined that the fire sprinkler system is required, or there is an existing fire sprinkler system. And then the next piece of the flowchart is you have determined that there is a space within your building or a space connected to your building that needs freeze protection and the coverage of a fire sprinkler system. So that is where this conversation sort of starts. Your building is sprinklered, or you have a new building or an existing building that is going to be sprinklered, and you have an unconditioned space. So for a code reference, we're looking at NFPA 13 and the section in the 2016 version of NFPA 13 that talks about protecting piping against freezing is 8.16.411, and the specific language for this code section says, where any portion of a system is subject to freezing and the temperatures cannot be reliably maintained at or above 40 degrees Fahrenheit or 4 degrees Celsius, the system shall be installed as a dry pipe or preaction system. So let's talk about dry pipe and preaction system first as an option for freeze protection. The definitions section of NFPA 13, and again we're looking at the 2016 version of the code, section 3.4.5 states dry pipe sprinkler system. A sprinkler system employing automatic sprinklers that are attached to a piping system containing air or nitrogen under pressure, the release of which, as from the opening of a sprinkler, permits water pressure to open a valve known as a dry pipe valve, and the water then flows into the piping system and out of the open sprinklers. So this touches on the main feature that keeps water from freezing inside of piping. That is the main problem with providing a wet pipe sprinkler system in a unconditioned space, is that the expansion of freezing water will rupture the piping. Put over time, even small amounts of water in piping will cause fractures and weakening of the integrity of sprinkler piping. So that is the key value of dry pipe systems, is that they are not normally filled with water. They're filled with air and or nitrogen as described in 3.4.5. Now, why would you want to have nitrogen filled in a dry pipe system? Well, dry pipe systems are notorious for corrosion because of the water-air interface inside of the piping. Now, you might be asking, well, didn't you just say that you didn't want any water inside of the piping? Well, testing for dry pipe systems has you release water into the system in order to show the time for the fluid to reach one of the most remote sprinklers. And so when you do this kind of testing, you fill the system with water, and unless you've designed the system extremely well, there are going to be portions of the system in which you cannot get water out of, and there will be a water-air interface in which corrosion will be greatly encouraged because of these system conditions, and there will also be a potential for freezing to happen. Dry systems are sometimes unavoidable, but present a lot of problems because of this corrosion. The system lasts anywhere from about a third to a quarter of a wet pipe sprinkler system's normal lifespan. If you can rely on a wet pipe sprinkler system to last 30, 40, 50 years, you may only be able to rely on a dry pipe sprinkler system to last anywhere from 7 years to maybe at the maximum life, probably around 20 and change, I would imagine. Using nitrogen instead of compressed air is a very effective way to reduce the corrosion inside of dry pipe systems. Nitrogen generators or a way to nitrogen inert your dry pipe system will add cost implications, but it will save you cost on the long-term maintenance and lifespan of the system. So like the definition described, there is a differential valve in a dry pipe system that is activated when a sprinkler head opens. Dry pipe systems use closed sprinkler heads, and when the sprinkler head is opened due to thermal characteristics of the sprinkler head, the frangible device, whether it be a glass bulb or a mechanical fusible link, will melt or burst and release air or nitrogen from the system. Once enough air or nitrogen is released, the differential valve will activate and open, which will flood the system with water, and the water will have to push the air out of the piping in order to send itself out of the open sprinkler. Dry pipe systems have volumetric limitations placed on them. Common volume thresholds for dry pipe systems are 500 and 750 gallons. There are additional equipment requirements that are required when you exceed these volumetric capacities. Here's the definition for preaction sprinkler system. A sprinkler system employing automatic sprinklers that are attached to a piping system that contains air that might or might not be under pressure, with a supplemental detection system installed in the same areas as the sprinklers. So, single and double interlock preaction systems always kind of gave me trouble early on in thinking about these systems. A single interlock preaction system needs one of the two options to happen in order to activate the differential valve that we talked about previously for dry pipe systems. You need a initiation device or a sprinkler head opening in order to trigger the differential valve for the preaction system. A double interlock preaction system is a system that needs both a sprinkler head to pop and an initiation device to activate in order to release water into the system. I've seen these systems used fairly frequently in data center rooms. I'm not a big fan of them. There are more features required to install these systems, and so there are more reliability concerns with the added sequence of events needed to operate in the instance of a fire. Preaction systems and dry pipe systems are more expensive than wet pipe sprinkler systems. The expensive valving, and in the instance of a dry pipe system, the added drains and the need to have code required pitch for the branch and sprinkler mains are a additional design implication or consideration. If you have a space with a limited amount of ceiling cavity or area to run sprinkler piping, you have to take special consideration for the pitch in a dry pipe sprinkler system. For instance, I was doing some work on a parking garage, and there was very limited clearance between the drive lane and the parking structure. So there is a minimum amount of space that the building owner wanted to give the largest vehicle that would be in the parking garage, and we had to really be mindful of the piping routing and the sprinkler placement inside of the parking garage. One of the other really common options for freeze protection is dry barrel sidewall heads or extended coverage dry barrel sidewall heads. This piece of technology looks like a piece of sprinkler piping attached to a sprinkler head, most commonly a sidewall sprinkler head, although this technology comes in the form of pendant and upright sprinklers as well, although I can't imagine a time where you would put in dry barrel upright heads, pendant for sure and sidewall, but fairly positive they come in dry barrel uprights as well. These sprinkler heads are connected to wet sprinkler systems, but they are used for the coverage of areas that are unconditioned. So a common application for this technology is, say, if you have a loading dock that is approximately 15 foot in width on the exterior of your building, and you don't want to add a antifreeze or heat trace system or dry pipe system, so you can get away with, if you can find a sprinkler listed for the 15 feet, which you can, providing sprinkler coverage from your dry barrel sidewall heads installed on your wet system inside the building. That piece of empty piping between the sprinkler head and the connection to the wet pipe system is used as a insulative barrier of sorts in order to provide a small gap so that the piping in the exterior wall of the building does not freeze. Dry barrel heads are a great option because they are a bit more expensive than normal sprinkler heads, but they are far less expensive than dry pipe systems or preaction systems if you can get away with it due to the exterior configuration or interior configuration of your freeze protection space. But as you can imagine, there are some definite space configuration limitations for using these sprinkler heads. Triflex heads are another option for freeze protection spaces. These are even more costly than dry barrel sprinklers, but they have more flexibility in the configuration that you can place them in. I believe that they have links They are up to 4 foot and maybe even 6 foot or 8 foot as far as how long the flexible extension between the water charged piping and the sprinkler head. Looks like there is a 38-inch, a 50-inch, and a 58-inch dry flex head listing. So those are a expensive, but could be based on the savings in installation and the elimination of the requirement for a dry pipe sprinkler system, a advantageous solution for freeze protection required spaces. I think that's going to do it for this episode. Apologize, didn't get to heat trace, but that would be a great topic for an episode on its own. We'll see you next time, and thanks for listening. Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.